Welcome to part 4 of Analytical Geometry. In this part, we're looking at intersection and shapes. The first part, intersection, simultaneous equations. We'll just do one example to see that. In the second part, we'll look at shapes, altitudes. You can see what's on the screen there, and we'll look at that in the second video. Okay, so let's dive and jump straight into it. Determining the point of intersection of two lines. So we could get asked this question with a picture. And I've drawn my picture. If you've watched these videos, you'll know the visual is so important just to get a sense of what's going on. Or we could get asked the question just straight up with text and without the picture. So I've drawn the picture here of the question that's given. It says, determine the coordinates of the point of intersection of the two lines 2x minus y equals 4 and 3x plus 2y equals minus 1. So in picture form, what we're seeing is, find this point over here, find me where the two graphs are kind of equal to each other, where they intersect. So we can see from our picture what it looks like our answer is. Now, I know that the answer is going to be 1 minus 2. I'm not just guessing to say, hey, it looks like it's at 1 here, because we couldn't be that accurate. So what we're looking at is, when is this one line equaling the other line? Now we've got our two equations, right? 2x minus y equals 4. And our second equation, 3x plus 2y equals minus 1. So to look at the algebra of this, what should jump out to us as we do more of these is to go, we've got two equations and two variables. And that just screams out for simultaneous equations. In other words, let's do some manipulation so that we can use our two equations with two variables to get one equation with one variable. Okay, so a strategy that's going to work algebraically is, let's look at this equation here and rearrange so that instead of 2x minus y equals 4, we've just got y on the one side of our equation, and on the right-hand side, we've got everything else that doesn't have a y in it. So if if 2x minus y equals 4, then y equals 2x minus 4. Okay, so that sometimes we label these and go, let's call that equation 1, or this equation 1 and that's equation 2. Maybe sometimes that's more the convention. That's 1, this is 2, this equation here was the other equation we were given 3. So what we can do now is say, well, this y here should end up being minus 2. And this y over here should also end up being minus 2. In other words, they should be the same thing. That's what we're trying to see. When is that y value the same? So we can take this equation here, 3, call it equation 3, and said, well, 3x plus 2y equals minus 1. But in this case, we've got another way of writing y, and that is 2x minus 4. Now what we've done is we've turned our two equations with two variables into one equation with one variable. So we can solve this equation over here and go, well, 3x plus 4x minus 8 equals minus 1. 3x plus 4x is 7x, plus 8 on both sides is 7, so x equals 1. Okay, now we've found out this one over here. And what we're trying to find is those full coordinates, right? So we know that x is 1, and we're trying to find out what the y value is. Now, I already told you at the beginning it's minus 2. That's what we're expecting here. But let's see why that's the case. We could substitute it into any of our equations we've got now, 1, 2, or 3. But I think, and perhaps you'll agree with me, it makes sense to substitute it into this equation, 2, 1 minus 4, because we've already isolated y. We have made y the subject of the formula. So we can just go 2 times 1 is 2, 2 minus 4 is minus 2. Now notice the way that I'm finishing off the question is to go, not just x equals 1 over there randomly, y equals minus 2, but the point is that we found a point, 1 minus 2. That's what we found as our point of intersection, not just a random x value and then a y that's not linked to it. These two things here, they go together. It's 1 minus 2. That's 1 point. Okay, so that's simultaneous equations and point of intersection. So you can use this concept in a different number of different ways. I see in part 2 where we'll look at some shapes and other ideas.